So hello everyone. I hope you enjoyed the meal, the nice meal we had. Thanks again for the organization, and the dinner yesterday was perfect. The meal was perfect, so I'm delighted. And I would like to present you this very long topic, or very long title, but we will try to come to try to reduce the title to something that makes sense. So this is basically the agenda we are going to see today. And first of all, I want to just present myself because I'm new in the hpc-ch community. I was previously working in France for more than 10 years in the storage and file system industry, mainly as a file system engineer, very specifically I would say as a Lustre engineer. Whether that's good or bad depends on the views. But since this is since some months ago, I moved to ETH Zurich, where I'm seeing now things from the other side of the wall, and I have to say that it is extremely interesting to see now the views on this side of the wall. So I think we already presented a little bit this morning scientific IT services in ETH Zurich, but since I come from the HPC group, we are managing the clusters of the IT centralized systems, the HPC clusters. Just to present you what we are managing, we have basically two clusters. One is here in Lugano, it's Euler, and the other one is in Zurich, Leonhard. It is smaller, but while Euler is a typical HPC cluster, a general purpose HPC, Leonhard, we will see today that it is more specific to do some special projects. And basically, we have in Euler, in terms of the storage, we have for the homes, we have a NetApp fast system, while for Scratch, we will have more a Lustre file system. And in Leonhard, we will see why we are changing from now GPFS to Lustre, and we have also as well the NetApp fast file system. So the context of Leonhard, it is the personalized health in Switzerland. So since around 1 year, 2 years ago, there is this initiative which is called SPHN, which tries to actually power up the personalized health research in Switzerland, and by several means, fundings, and starting projects and approving projects, where the core of the initiative is the personalized health research. So I don't want to extend too much on the actors and on the way this is done, because this is not my domain. If you need more information or you want more information about this initiative, I think you can ask, for instance, my colleague Christian Bolliger, who will provide more information. So this is the nice machine we are presenting today, or where we are presenting our work today. This is Leonhard in Zurich. As you can see on the left, there is a storage, which makes a lot of sense if we are in a storage forum. So we are speaking about personalized health research, which means probably that we are handling medical data. With medical data, confidentiality kicks in very quickly. But at the same time, we obviously need performance. We probably need to make it easy to use, because there will be doctors making use of this cluster, of this system, of this platform, as we prefer to call it. So we probably don't want the doctors in the hospital to be running Lustre mount commands or things like that. Well, I would love to see that, but I can understand them. So we probably need to facilitate things for them. So it needs to be easy to use, and obviously the researchers are asking us for a flexible platform and not for something extremely fixed, where there is only one way to use it and there is only this reduced set of applications, or this reduced set of things that you can do with this system. So there is obviously the security that kicks in very quickly. And obviously, in this cluster, there's the physical security where the access to the room is strictly restricted to authorized personnel. There is a two-factor network authentication. Of course, there is let's say that the firewall is way stronger than it could be in any other HPC general purpose cluster. So there is, for instance, no access to internet, or if there is access to internet, it needs to be for specific pages or specific sites that the researchers ask us to open. So this kind of gives you a nice idea of the level of confidentiality and the level that we are handling here. And of course, there are multiple projects in parallel, multiple medical projects, because we are not setting up a cluster just for this set of doctors. We probably are setting up a platform for many different researchers and different hospitals as well. So Lustre, why Lustre? Well, first of all, this presentation was done 2 weeks ago in a Lustre workshop, so this is also why it is quite oriented for Lustre, because we are trying to present a use case for Lustre, where for us it makes a lot of sense. It was first GPFS, right? We are not going to evangelize here with Lustre without saying this. So why it was GPFS and why we are moving from GPFS to Lustre? First of all, when we choose GPFS, when it was chosen by the team, this was a requirement by the users, saying we are handling medical data. This is confidential. It is very important to have it encrypted. We understood that as, okay, it's extremely confidential, so encrypted, why not? But it was not actually what the users were asking. The users were asking just that nobody outside of the project can see their data, and that, of course, nobody can take the drive and see whatever is inside. But first, the room is secure, so this is not supposed to happen. And second, encryption is a solution. It's not a requirement. And the requirement is probably isolation. So what the users wanted to say is, I need isolation, not I need encryption. So GPFS at the time was doing good encryption, so we did encryption. But then we hit some limitations on this setup. Like, for instance, we can only have 8 different encryption keys. That means that if we have more than 8 different research projects on this platform, we probably need to have another GPFS cluster coming in, which, of course, that means that's an expensive solution, and that doesn't allow very well to grow. So this limitation of 8 encryption keys was already a first big stopper. There's also the problem of the root squash in GPFS clusters, that with Lustre we can do a mapping of the UIDs to have root squash. And on VMs, for instance, you need to re-export GPFS as NFS, but we are in the performance business, so maybe this is not ideal. Finally, the network isolation is also a problem, because in GPFS, all nodes need to see each other. So in Lustre, the Lustre network, the LNET layer, gives us more flexibility to do these kind of things. So in GPFS, that means, in general, that we need to have different GPFS clusters, 1 per tenant, which is also it does not seem like an affordable solution. At the same time, during the last year and a half, Lustre multi-tenancy has kicked in. So with that, we are not saying that GPFS is, sorry, you can see here. So we are not saying that GPFS is not good or is not great, but there are use cases. And we think that in this specific and particular use case, Lustre fits better our needs. And then also, well, this is a brief summary of why we also like Lustre and the nice features it has. It's open source. There are good community experiences on multi-tenancy and the network flexibility, as I said, and it scales the performance. We have no worries about that side. So the multi-tenancy in Lustre, I guess not everybody is here not everybody knows well what multi-tenancy in Lustre means, but in general it means that you have isolation, so you have, we can say, I like to say that we have a cluster of clusters, but what this means is that users think that they are, I like to think that users believe that they are alone in the cluster, and the cluster is themselves and their machines, and that's all. Because there's network isolation, so you cannot see other nodes doing other things. And because the storage seems to be quite unique for you, you don't see other mount points, you don't see other subdirectories that don't concern you, so you actually think like that you have a Lustre file system for yourself. And so this is very interesting from an admin perspective, because that means that as an administrator, even if I have multiple users, multiple tenants, I only have to administer one file system. I only have to do the backup of one file system. And so it is no doubt the resource sharing made effective. And as I already said, in the Lustre community, there have been already good experiences. So it means that we are not the first ones doing this, which is, especially Lustre, it is always good to know that you're not the first one to try this. So this is basically the view that I would have as a tenant on Lustre. So I have my set of nodes, I have my network, and then I have my Lustre file system, which is actually the Lustre file system is project A. So because I'm a user of project A, I'm happy to see that there is only project A, and I cannot, of course, see project B, project C, project D. But as an admin, I want to see actually this. So I want to have different projects, but I want all of them to be in the same file system. And also as an admin, I want to be able to access the entire file system, but I still want to access the file system with other nodes accessing only their share. So typically, this is the typical sysadmin view in Lustre. This is done by adding special machines which are called LNET routers. So these LNET routers are actually just forwarding the Lustre packages to the servers. They are making so this is not the router as we usually know in the network industry, but these are just servers that do a layer 4 forwarding. So this is the way it's been done until now. So at ETH Zurich now, I know the name of the presentation is multi-tenant, and I've been using multi-tenancy several times today, but now I want to change this name. And I want to change this name because at ETH Zurich we are having projects and not tenants. The reason is that usually tenant implies one tenant, one user, while we don't want to do that. The previous implementations of multi-tenancy in Lustre involve systems where there are 300, 500 tenants. That means that they have an open stack environment where they run VMs, and each user is a tenant, so each user has its own network, its own Lustre file system, and then, well, with 300, 500 tenants, you need to have different solutions. But at ETH Zurich, we currently have 5 tenants, and we are soon going to have some more tenants, but these tenants are a group of researchers. So it doesn't make sense for us to speak about multi-tenancy, but we rather prefer to speak about multi-project, because that really reflects the scale of the scale we are handling here and the scale of our tenants, which are more than one user. So, a project is basically a group of researchers that are researching over the same data set. The patient, we need to think that in the personalized health environment, the patient is giving authorization to use his data for this, but not for this. So that means that a researcher, when he goes and he do research on a data, it needs to sign that it will reduce his research to this specific data. So a project is driven by data set. This is an architecture where the access to the data is driving the architecture of the network and the architecture of the cluster, of the platform on itself. So that's what we call a project. And a data set is what is a set of data that belongs to a project, and that's typically, to speak very clearly, that's typically a subdirectory in a Lustre file system. So because we don't have that many tenants, we don't have 300 tenants, but we are only speaking about tens of tenants, we think that a good solution is to use VLANs. VLANs fit very well with the kind of service we are providing. You need to think that we are not an OpenStack provider, so it is not like we are providing VMs to the researchers. We are providing often bare metal, so that means that a researcher will come and will say, I will need 8 nodes for this project, I will need 10 GPUs for this project. So this gives the researcher the choice to choose whatever they want to use in their platform, in their systems. So in this case, it doesn't make sense for us to use a LNET router, which is what typically has been doing the Lustre community. And a Lustre router adds overhead, of course, because it's a middleman. And a Lustre router needs also to be managed. That means that each time you have a new tenant, you need to set new systems to manage the traffic between your project and between your storage. So we have removed this router limitation. We have VLANs. So a node in a project lives in a VLAN, and then the storage is connected, obviously, to all VLANs, and it is exporting Lustre specifically files. It's exporting specific data sets to specific VLANs. That way, if I live in a VLAN, I cannot see the data from all other researchers in this case, because the Lustre, in this case, Lustre is handling this. So this, we are doing this with, this is the hardware where we have, in this case, we have Ethernet switches with Mellanox, and then we have in Lustre logical networks. So the Lustre networks that are handling this and that are mapping the data sets to the VLANs to the projects. Then simplified multi-tenant or simplified multi-project becomes a bit more complex, because some researchers came later and said, well, now actually I need isolation, but I would also like to access 2 data sets at the same time, 2 confidential data sets. So this is counterintuitive, because that means that you could actually mix 2 data sets, and this is very dangerous. But some researchers have access to these 2 projects, and they want to do research on the 2 projects without having different nodes, different clusters, we could say. So in this case, with Lustre, we discovered that we can actually do this by creating a more advanced architecture where we have several Lustre logical networks living in the same VLAN. And in this way, we can create different mount points, so the user thinks that they have access to different Lustre file systems, each one with their data, but it's still living in one unique file system, which is very nice because it provides flexibility. There are golden rules, of course, for these researchers, which is please don't move data between projects, because otherwise you are mixing confidential data, and that's a mess. But that's another topic, or more on training users on these kind of clusters. So this is basically the Lustre view of the system. it is a little bit Lustre technical, but it provides a good view on, we have a simple project on red and on pink here, on purple, where we can access just one project, but we have a special group of researchers, in this case, for instance, in blue, that they can actually access both projects. So I don't want red to see blue, and I don't want purple to see blue, because they could have access to the other data set. So that means that they live in different VLANs, but each one of them can easily access their data. And well, it actually works. It just requires very specific, and I would say careful, LNET handling, Lustre network handling. So for the next months, we see the evolution of these clusters, of this platform in many ways. For instance, LNET routers can still be added, and there are use cases where an LNET router could make sense. Let's just imagine that we have a new researcher that comes in and says that he wants 20 nodes and that he will deploy a OpenStack solution. In this case, we can put routers in the middle that will provide the access they need to their 20 or 30 tenants, in this case, if they have tenants. So it provides the flexibility we need without changing too many things. And there is also the need of maybe having remote access in the future to the data. In this case, well, we might think of Kerberization of the tenants, because Lustre is now offering this possibility. We can just authorize, use Kerberos to authorize selected nodes of whether they are authorized to mount the file system or not, or we can actually encrypt the data, which obviously doesn't come for free in terms of performance. And then in some years, I might say, in the next long-term supported Lustre version, we have interesting features for a medical cluster or a medical platform like this one, like, for example, on data on metadata, or dynamic file striping, which makes that you don't need to care about where do I put my data, in 10 drives, in 40 drives, or in 200 drives. So these are new cool features that are coming in, and of course, audit on change logs, which is something that for a platform where we have confidential medical data might be extremely important. So I just want to finish with some conclusions where I think we have now Lustre as a solid choice for our platform, for Leonhard. It could deserve the Lustre security issues, and in general, the parallel file system security issues deserve a presentation on themselves. Parallel file systems, I do not think they are yet ready to be open to the internet if there is confidential data. There are still lots of vectors of attack that we need to deal with. And in this case, we are presenting, and this is the news here, that we can do a more simplified multi-tenancy without LNET routers if we don't have that many tenants. So yeah, finally, it's also a good thing to see that actually this is a platform where the data access is driving the choices we've made in terms of networking, in terms of parallel file systems. So it is really a data-driven platform. Last but not least, and as a small joke, I always like to think that if I live in Switzerland, since this is personalized health research, maybe I will live longer thanks to Lustre. So with that said, thanks for listening, and thanks for the team who has helped developing this. And if you have any questions.
Any question for Diego? Then I'm curious, and I will be provocative on purpose. So you don't look for encryption, clear why. So you did the segregation or whatever, isolation. And why on the same file system, not putting more file system on the same cluster? Because I'm asking because you had GPFS, so you wanted to move to different thing, but you can achieve the same just doing different file system. If your point is to do different mount for specific directory.
In my case, let's think now that I have 240 drives on my RAID controllers. So how do I do this? How many drives I dedicate to this project? And what if this project then comes in and says, oh, now I need 500 terabytes more? How do I manage this? Do I pick up some drives here and allocate to other project? I need to have some, in this case, we need to have some elasticity. Having one unique file system, we have this elasticity where we actually, with project quotas or with directory quotas and with other mechanisms, we can get to this point where we can dynamically allocate the space to projects or shrink or expand with projects. Otherwise, I will need to make static choices on the hardware. And it is very important not to have this. And what if I grow above the number of RAID devices that I have, then I will need to partition my RAID devices in several drives. So
that's because you wanted to reuse the hardware you had, or because otherwise you go to a SAN, you buy even cheap.
Otherwise, I go to what?
You simply change the kind of hardware you have. You go to a SAN, you have elasticity, because you are talking about DDN there. That's the constraint you have with DDN, but not specific to any hardware. So if you are going to buy to solve the issue, you can buy different hardware to have this elasticity. I'm just being provocative on purpose.
Of course. That's fantastic. No, so it is because I'm choosing, what I'm choosing is the Lustre technology because I need, as I say, I need performance. And in Lustre, who is going to provide me this? I don't have that many choices in this case on who can provide me the Lustre technology to do this. And on top of what I have this, on top of JBots, maybe if I have JBots, then I have to choose a ZFS backend, and a ZFS backend requires a Ninja Lustre to manage it. So,
yeah, I agree. I honestly was thinking also about BGFS, just jumping on the next presentation too. Have you evaluated that one as an option?
Yes, but we are very concerned of so with BGFS, we are extremely concerned about the metadata failures and the problem of the failover. In this case, we are not sure our users, we can tell our users to reproduce their data or to rerun their data because the cluster went down. So in this case, we need to have a good balance between the long-term data and between stability in this case and performance.
Makes sense. Any other question for Diego?
So you mentioned that you are not provisioning any virtual machines in OpenStack and nothing similar, but it seems like you are using Lustre as the guideline to provide computing resources and computing storage. But did you evaluate or consider OpenStack plus the other facilities? So OpenStack as a driver for the storage, as a driver for a shared file system, as a driver for bare metal through the Ironic. So I don't know if you have a look, just to be provocative.
I will try to reply as best as possible because I cannot speak about the choices because I was not at the team at that time, but I can speak about my current view. And in my current view, for instance, I don't want to impose virtualization to everybody, to all the researchers. This is a cluster where we have also one specificity, which is GPUs. So GPU virtualization, okay, it's getting better, but let's say about a year ago, a year and a half, it was not yet there. And I will also to provide, so as I said, we are more a bare metal provider. If I'm providing OpenStack environment, I'm not a bare metal provider. I'm providing other kind of service. So if as a researcher wants to have an OpenStack cluster, they still can have this. If a researcher wants to have a CentOS 7 cluster with bare metal and they know what to run, they can still have it. So the nature of the service we provide, we cannot provide it was an option, I think, the platform, but it is not the kind of service that we are providing, this kind of OpenStack platforms.
I can add to that. One rationale is we don't have the 3 to 4 person years you need to set up OpenStack. And the other one is performance. Some users said we need more than 10 gigabytes per second. Will be difficult to virtualize.
Any other question for Diego? Then thank you, and we go to the next one.